Hello mathematicians, thank you for joining me today as we try to find the determinant of a matrix A, which is given as above. Now in order to find our determinant here, what we're going to do is use the formal definition, and so what we have is that we define the determinant recursively as we would take, say, this entry times the determinant of the matrix that's left over. If I delete this row in this column, I'd work my way across. And I do that for every entry in a given row or a given column. And so since I'm going to do it that way, what I want to do is first decide which row or column should I use. And so as I'm doing that, I want to pick things with hopefully lots of zeros in them so that it'll make my work easier. Now as I look at this, I notice that there are indeed 2 zeros in the first column. There are 2 zeros in the first row. Either one of those would be good choices, so I'm going to work with the first column. And so what we're going to have is that the determinant of A is going to be the sum from I equals 1 to 4 of the terms in A sub I comma 1 times -1 to the I plus 1 times the determinant of the matrix left over after I remove the ith row and the first column. So using our sum notation here, the determinant is just the sum of these terms. And so what I want to do is I want to write down what each of those are so that I know what I have to find. In particular, if we look at A sub 1, 1, plugging in 1 for I get 1 times, and if I plug 1 in for I get -1 squared, times the determinant of the matrix, m sub 1, 1. And then I'm going to plug in 2, so I get A sub 2, 1 is 0, so plus 0 times -1 to the 0 plus 1 is 1, times the determinant of m sub 2, 1, plus, and then the third row, first column is 0, to the -1 to the 3 plus 1 is 4, and then times the matrix that's left over. And so what I have is m sub 3, 1. Now I have plus. Now the fourth row, first column is 1 times -1 to the 4 plus 1 is 5 times the determinant of the matrix when I remove that row and column. And so what I'm going to get is that the determinant of this matrix is going to be, well, I just have to now add these things up. Now notice that in order to add these things up, I still have to calculate what the determinant of these smaller matrices are. So I have to find those matrices and then find the determinant. Instead of trying to do that all at once, what I'm going to do now is break this up into different problems and say, well, what is this matrix and what is its determinant? What is this matrix and what is its determinant? And now if I had to, I would do these, but notice I'm taking 0 times something, which was the point of choosing a column or row with zeros in it. Since we're taking 0 times something, we know that's going to be 0. So we really just need to find these two things so that we can plug in when we're done. Now, before we go ahead and do that, let's go ahead and find what those matrices are going to look like. And so what I'm going to point out here is, if I want to find m sub 1, 1, or the minor with the first row, first column removed, is I'm going to look at A and I'm going to imagine deleting that row and column. So my remaining matrix is 1, 0, 2, 3, -1, 1, 2, 5, 0. Therefore, I'll have to find the determinant of that matrix. Alright, so now we want to find the determinant of our minor sub 1, 1. And what we need to do is work with this 3 by 3 matrix. And so again, we're going to do a similar thing where we take an entry times the determinant of the matrix that's left over. And so as I look at this, I want to find, is there a row or column with zeros in it that would make things a little bit easier on me? And so here I'm going to go ahead and use the first row, because there is a 0 here, and we have a 1 and a 2. So hopefully it's not too difficult to find. Because I'm using the first row, my determinant of this matrix is now going to be the sum from j equals 1 to 3 of A sub 1j times -1 to the 1 plus j times the determinant of the matrix that's left over after I remove the first row in the jth column. And now I'm going to say M prime here to denote that it's the minor from this matrix as opposed to our original, because we're already using M sub 1, 1 here, so I don't want to get those confused. But then what I'll do is just figure out what these terms look like. So if I plug in 1 for j, I get a sub 1, 1 is 1, times negative 1 to the 1 plus 1 is negative 1 squared, times the determinant of the matrix M prime sub 1, 1, plus 0 times negative 1 to the 1 plus 2 times the determinant of M sub 1, 2, plus, and now the third term is 2 times negative 1 to the 1 plus 3 times the determinant of M sub 1, 3. Now, as I go ahead and calculate these, what I'm going to have to do is find these determinants. Notice that now these matrices are going to be 2 by 2 matrices, so as we find those, we can go ahead and just take, well, the determinant of a 2 by 2 is a times b minus, or a times c, a times d minus b times c, and so we can go ahead and do that as we go along. So if I look at M sub 1, 1, notice with the first row, first column, my matrix is going to be negative 1, 1, 5, 0. So the determinant is going to be negative 1 times 0, 0, minus 1 times 5 is negative 5. So if I follow this through, I get 1 times negative 1 squared is 1 times 5 is just 5. Or negative 5. And then plus 0 times this is just 0. And then I would take 2 times negative 1 to the 4th is 2 times the determinant if I remove the first row and third column. So that's the first row and the third column. So what I'm left with is 3 times 5 is 15 minus negative 1 times 2. So 15 plus 2 is 17. So what I end up with is negative 5 plus 2 times 17 is 34. 34 minus 5 is 29. So I get that M sub 1, 1 is indeed 29. Now that we found the determinant of M sub 1, 1, we have to find the determinant of M sub 4, 1. And so we're going to do that in a similar way. What we want to do is pick a row or column, hopefully that has some zeros in it to make our life easier. And so what I'm going to choose here is, say, the second row. So since we're going to do this using the second row, we're going to get that the determinant of M sub 4, 1 is the sum from j equals 1 to 3 a sub 2j times negative 1 to the 2 plus j times the determinant of M prime sub 2j. So now again, we'll fill those in as we go and see what they're going to be. So a sub 2, 1 is just 1 times negative 1 to the 2 plus 1 is negative 1 cubed is negative 1 times the determinant of M sub 2, 1 plus 0 times negative 1 to the 2 plus 2 is 4 times the determinant of M prime sub 2, 2 plus 2 times negative 1 to the 2 plus 2 times the determinant of M prime sub 3, 1. So now this is what we're going to have for the determinant of this matrix. Now if I follow through, what I end up with is 1 times negative 1 is negative 1 times, and now the matrix M sub 2, 1 is, I'm going to remove the second row, first column. So if I look at the determinant of that one, I'm going to get 1 times 1 minus 1, negative 1 times negative 1. Negative 1 times negative 1 is 1, so I get 1 minus 1 is 0. Now for the next matrix, I have that I'm going to be multiplying by 0, so I don't have to find the determinant of this. I know this is just 0. And then if I look at this next one, I get plus 2 to the negative 1 to the 2 plus 3 is to the 5th, so negative 2 times the determinant of remove the second row, third column. So I'll remove the second row and the third column, and so what will be left is 2, 1, 3, negative 1. So if I multiply that, I get 2 times negative 1 is negative 2, minus 1 times 3 is 3, negative 2 minus 3 is negative 5. So if I add this together, I get 0, 0, negative 2 times negative 5 is positive 10. So I end up with the determinant of my m sub 4,1 is exactly positive 10. Alright, now we can go back to finding the determinant of our original matrix. And what we had found was that the determinant of A was 1 times the determinant of m sub 1,1. Now, we found that that was going to be 29. So I'll get 1 times 29 minus 1 times the determinant of m sub 4,1. And now we had gone off to the side and found that was going to be 10. So what we'll end up with is 29 minus 10 is 19. Therefore, the determinant of A is exactly 19. Thank you for watching. As always, I hope you learned something today, and I hope you enjoyed the process along the way. If you did, make sure to like the video and subscribe to the channel. It helps me to know which videos are helpful, and it helps other people to find these videos so that they can also get help. Thank you.